to semester 2. We are going to finish unit 4, which we did not finish during semester 1. So I'm going to keep going with this, and hopefully if you're new to me, there's not too many of you, but you'll catch on pretty quickly. I'm sure you will. You need to be taking notes in your notebook. I will be checking that you took notes, appropriate notes, and giving you a check mark for them. And then you need to be doing the homework in your notebook as well. So we're going to be talking about graphs of exponential functions and an inverse, the graph of its inverse, which is a logarithmic function. So that's what you need to be focused on today. So I want you to pause this video and graph these on Desmos. It says in your group. It's because I did this in class last year, but if you're with somebody, you guys could discuss this. But I want you to be graphing these, maybe take a note of them, jot them down. What's the y-intercept of these functions? What's the domain? Remember, domain is what numbers can I put in? Do you think that it's growth or decay? So growth would be getting bigger, and decay would be getting smaller. And then if there's any similarities and differences between any of these graphs. So those are some notes I want you to take kind of on your own. When you are ready, go ahead and keep, play this video again, because on my next slide, I am going to show you some graphs of this. And then, hold on, there's someone here. I don't think he's coming in today. So you are going to, I'm going to have them graphed, and then you are going to take some notes on them. So maybe if you want to jot down the graphs in your notebook, as well as these, like the y-intercept, the domain, and then the growth and decay. So go ahead and play when you are ready. I graphed all of these for us. So what I did is, let's see, this is y equals 2 to the x. This one is y equals 1/2 to the x power. This one is y equals 2 times 2 to the x. And then this one is y equals 3 to the x. So my question on all of these was, first off, the y-intercept. So I'm going to use a different colored pen to find the y-intercept. So in this case, I just disconnected my microphone. I'm hoping it's back in. Just disconnected my microphone. I hope that you guys can still hear me. I'll try to possibly edit that out. This is my y-intercept here. So it's 0, 1 in this case. Here it's again 0, 1. Here it's 0, 2. And here again it's 0, 1. This one doesn't look like a 0. All right, so if I'm looking at these and I'm matching these up, you will see that if I put a number 1 here, I'm going to put 1 times, 1 times, and 1 times. And I did that because all of these that have an intercept of 0, 1 don't have a number in front of them like this one, okay? So in that case, it's 1, and that is where the y-intercept is. So the y-intercept is always this number in front, y-intercept, okay? The next thing was the domain. So hopefully for the domain for all of these, you notice that the domain, put it over here in blue, is all real numbers. The range, though, is all real numbers greater than 0. And we've talked about this before. No matter what number I put in, I can never get out a negative number. I can't even get 0, because anything to the 0 power is 1. Okay, so all real numbers I can put in, but for the range, and you'll see that there's an asymptote on all of these. The asymptote is at y equals 0 for all these. It kind of hugs that and never goes below it. So that's the domain and the range. The similarities and differences. Ooh, you were supposed to answer whether it was growth or decay. So hopefully you notice this was growth, growth, and growth, because they all got bigger. Really, really fast they got bigger. This one is decay, and that goes with 1/2 to the x. So similarities and differences. The similarities would be that the growth ones all start small and get bigger. The one other thing I want you to notice is that this number makes a difference of if it gets bigger faster. So this one gets bigger faster because of that 3. So I put this on here because I wanted to kind of break it down. Remember, this tells us where the y-intercept is. I like to think to myself, oops, I want where it starts. And then this one is how it changes. And this tells us a lot, actually. If b is greater than 1, this is a growth function. And if b is between 0 and 1, usually like a fraction or a decimal, then it's decay. When x is the exponent, that's how I know it's an exponential function. So the homework, which I'll put online, and especially if you're new or you need a reminder, it's your classwork that you should be doing with your table partners in class. It's going to be a book assignment. I will put the book assignment online as well. And you will have some time to work on this in class. You will need to remember parent functions to do this. And that was on the final, so I think we'll just do it anyway.